We have some tricks on moving the blocks which will help us in finding the simplified, let's say, block diagram for a given system. And maybe it would be, you may wonder why we need to simplify a given block diagram. We would need this when we are going to analyze the systems, and then later we will design controllers or compensators for the system. So if you have a system with lots of blocks connected in different ways to each other, then designing a controller for the system might not be an easy task. But then if we combine them and simplify the whole thing into some standard block diagram system, our task will become easier. So over here you can see how we can move the blocks before and after a summing junction or a summing point. In the first case, we are considering this case. So the block G of S is after the summing point, and we are interested in moving it before the summing point. In this case, the block will appear in both paths. So you can see that after the summing point, we don't have the block, it is removed from there, but then it appears on all the incoming paths. Let's see why this is the case. So what we have here as C of S is R minus plus X multiplied by G. And we can rewrite it in the form of R times G minus plus X times G. Okay, and now if we say that we put the summing point over here, now I think you can easily get it. Yeah, we need to have R times G and X times G signals. R times G is here, X times G is here, and then we have the same output signal C of S as before. On the other hand, if we want to move the summing point after the if we want to move the block, a given block after the summing point, we should do it in this way. It will be removed from here, it will appear at the output side, and then on the other passes, on all other passes, it will appear in the form of 1 over G of S. And again, we can see why this is the case. So if you consider C of S here, it's given in the form of R times G minus plus X. And then moving it after the summing points means that we would like to have some signal multiplied by G of S, which gives us C of S. Okay? And if we consider that signal to be here, for example, A of S times G of S will give us C of S. And another fact is that we will not have G of S multiplied by R before the summing point. Okay, so in other terms we can say let's divide everything by G of S, and then let's see what we will get. Yeah, if we do so, we will have 1 over G of S times C of S being equal to R minus plus 1 over G of S times X. Okay, so somehow we are there. We don't have C of S multiplied by R anymore, but we see that 1 over G of S should be multiplied by X, and then on the other side, the signal that we have right now is 1 over G of S times C of S. So if we want to get the same C of S signal, we need to multiply this with another G of S. That's why the G of S appears over here. So G of S is removed from the path that we have for R, 1 over g of s appears for x of s and any other input that we had for the summing point, and g of s also appears for the output side. So in this way we can move the blocks before and after the summing junction. If you want to do a similar thing for moving the blocks before and after a branch point, we will do it in these ways. So the first thing is to move the block, a given block like g of s, before the summing point. Okay, so we want to take it and move it before the summing point. You can see here that the block is removed from the path in which it was on the branch indeed, and it appears before the summing point. But now we need to have exactly the same signals as before for any of the branches. So if you look here, initially we had R times G for the first branch, then R and R for the next branches. And now that we have moved the G of S before the branch point, we already have R times G at the branch point. So if you want to have the same signals, we need nothing on the first branch, and we need 1 over G of S on any other branches in order to have exactly the same signal as before. Moving the block after the summing point is easier. It will just disappear from where it was and it will appear on all other branches. And I think this is kind of obvious how it happens. Over here we already had R times G as the signal, and on all the passes, all the branches, we had the same signal. Now that we have R at the branch point, we need to multiply it by G of S in order to have exactly the same signals as before. Alright, so in this way you can see that it's possible indeed to move the blocks or the systems before and after the summing points and the summing junctions, summing points, and the branch points. And these techniques will be useful when we want to simplify a given block diagram system in a one that we, let's say, are comfortable to work with. We will see examples later, and you will see that these techniques over there will be useful.